Hello, everyone. Thank you for attending this session. We are going to be presenting today how to migrate from SQL Server to Azure SQL Managed Instance at scale. After the presentation, please don't forget to provide us with feedback. We hope to provide something that is useful for you. And if you didn't like it or something was not up to your expectations, please let us know, as we would like to learn about those. With that said, let me first introduce myself. My name is Oscar Zamora. I am a solutions architect here at Microsoft, and I have been at Microsoft for a little bit over 2 years. During the first 2 years, I have been working within the data migration teams to help organizations migrate their data from on-premises infrastructure to Azure Data Services. And one of them has been SQL Managed Instance.
Hello, everybody. This is Avnish. I'm peer of Oscar, and I've been with this program same as 2 years, and we've been with Microsoft for 3 years now.
Thank you, Avnish. With that said, let's go through the agenda. We're going to first discuss about the Azure SQL Database tiers. We want to make sure we have clarity there. Then we're going to get into the managed instance capabilities. We will also provide to you a possible restore matrix for you to leverage as options as you restore from on-premises or VM into Azure SQL Managed Instance. We're going to go through the migration to Azure overview on how are we going to be approaching the scale of this migration. Then we're going to show you how to scale assessments with DMA. After that, how to scale assessments with DMS. And after all this presentation, we will be providing PowerShell demos for both DMA and DMS. After that, we will just discuss a bit of the post-migration processes, and we will get right into the Q&A session. All right, so let's talk about Azure SQL Database tiers for the sake of clarity. I want to make sure we are all on the same page here. Azure provides 3 different flavors of SQL databases that are compatible with SQL Server in a way. We have the single database, which is really the first implementation we have provided many years ago on Azure. The single database is a solution that allows you to plug in or migrate or create just one single database. Think about it as being a self-contained database. It's just one database running on its own service online. Then we have the Elastic Pool. The Elastic Pool was built for us to have the capability of multiple single databases with the opportunity of having some of them using more resources during certain period of times during the day and others maybe during the night. And that way we have a pool of resources readily available for us to leverage throughout the whole day as requirements from the single databases on this pool change. Some days it could be used a lot of resources, maybe because during the day there is a sales transaction that are happening, and during the night is more about just behind the scenes processes for updating data. And finally, on the right, we have managed instance, which is the core of our presentations today. Why are we choosing managed instance? Because managed instance resembles more accurately what you potentially have on premises. The database, the options, and of course, the database instance and its own single databases, which can have cross-database joins. And for the sake of this presentation, when we talk about cross-database joins, is within the same managed instance, within the same instance. So The main differentiator here is that managed instance resembles more to what you have on premises. Single databases and elastic pool resembles more of single databases in an efficient pool or single databases by itself or by themselves. Now, let's also add that we have two different tiers within this database tiers. One is the general purpose and the other one is the business critical. We're going to get into those details in the next slide. Finally, just for the sake of clarity, we introduced maybe a year ago or so the serverless feature, which is really a single database with the opportunity for you to have it inactivated in a way, so you don't incur any services charges if it's not being used. It could be a good opportunity for folks to have, for example, a development environment. And hyperscale was introduced for single database also like over a year ago. It provides capabilities of extending the capacity of storage to up to 100 terabytes on a transactional database. The architecture changes a little bit. It's not really the scope of this environment or this presentation, but we want to make sure that you are aware of this capability on Azure. Let's get to the managed instance capabilities. It's built on the same infrastructure as SQL Server on premises, but you have all the platform as a service benefits, right? All the behind the scenes, operational tasks for backup. Your SLAs are also up to 99.99% in the case of the business critical. You have built-in HA already pre-configured for you. It gives you the opportunity to also configure your retention periods depending on your requirements. You can perform your own initiated backups, and you do have the capabilities of point-in-time restore all the way up to the time your retention period started, which could be all the way up to 35 days standard. It's really 100% compatible with SQL Server. And you will see later on some of the slides, I can literally take a SQL 2005 and beyond backup and just restore it on SQL Server. Yes, there could be certain things that are not going to work, and we're going to get through those in a second. But the core objects and database are going to be able to be restored, and you're going to be able to access it from this managed instance. There is also security and compliance in place. You have the ability to have a private IP address with only private connections, not even access from the outside world. You have the opportunities to turn on transparent data encryption, to have your own VPN connectivity. And finally, you can leverage Azure Active Directory for authentication and single sign-on, and for server principals. And now we have enabled a few months ago also interaction with your local domain if you really need to leverage your local domain authentication. Let's get to the general purpose, very high level. In the case of managed instance, right? We have from 4 to 8 EB cores on the generation 5, which is the current generation. As of today, we have a maximum storage of 8 terabytes. IOPS up to 7,500 per data file, and depending on the amount of data files you have, it will grow depending on the amount of storage you have. So the highest will have the most files behind the scenes. You have auto backups in place and HA, which is based on remote storage. And finally, there is a key differentiator with business critical, which you will see on the next slide, which is storage. It's detached, right? So we have blob storage behind the scenes. The access time, I believe it's around 5 to 10 milliseconds on average. Most people will use this as a general purpose database. Now we have also the business critical. The core differentiators, as I mentioned, starting from the previous slide, is the storage. In this particular case, storage is attached to the database within the node as an NVMe. very fast access, in some cases, half a millisecond, some cases 1 millisecond. So it's much faster, 5x compared to general purpose. The same criteria of E-cores from 4 to 80. We have max storage as of today of 4 terabytes. There are a couple of things that are also added. You can leverage in-memory or LTP on this tier, and you will always have a read-only replica tied to the solution. You will have the opportunity to use this read-only replica for a reporting capability if you wish to deploy that. And on this architecture, we always offer secondary replicas 2 and 3 for the sake of a high availability. This is all done behind the scenes for you. All right, so let's get into the details of migration to Azure. And before we even get to the scaling piece, we want to make sure you have some clarity on the restore matrix for Azure SQL MI. On the left, I have a list of sources. We will assume that you can either start from SQL Server on premises or VM or AWS RDS SQL Server. And the targets. The targets will be single database, managed instance, and virtual machine on infrastructure as a service. We have DMS, which is data migration services, on online mode and offline mode. The main differentiator between those is that online means continuously updating from the source until you're ready to switch over. Offline means you will need to shut down your original source until the migration completes. So as you can see, we have, of course, AWS RDS compatibility with offline, whereas we only have SQL Server on premises or VM for DMS online. And the good thing is SQL Server is 2005 all the way to 2019. Now you also have the option to do your own backup and restore, leveraging the blob storage. And if you back up from any of these sources, you can restore into managed instance, and you can also restore into an Azure VM running SQL Server. So blob storage can also be performed. You can also restore from a local file, and only, of course, if you're going from a infrastructure as a service. This is a local file that is residing on the local machine. You can also restore that. You have the option to restore from Backpack. This is a feature you can leverage and create on your SQL Server using the SSMS tool. You can also use external tools to create backpacks. And this is usually a path for certain folks that want to migrate into a single database. You can also leverage for managed instance, and of course, you can leverage into Azure VM, running IaaS SQL Server. And finally, failover, a manual failover. As of today, that's only working or feature that is enabled if you are running a replica, AG replica, from on-premises, for example, replicating to a SQL Server running as infrastructure as a service on a VM. We have one more matrix just for the sake of having options here in case you would like to use different steps for restoring. Definitely, you can use data migration services. Is something we're going to be showing today. You can use it through a PowerShell. You can use it through the API. You can use it through the portal. Now, we also have the capabilities of using APIs. There are endpoints you can leverage. You can restore into SQL MI with no recovery. And this is good for scenarios where you need to apply a differential or a log to open the database later. We have seen certain situations where this is actually working well for customers. You can restore from URL. That means in a blob storage using T-SQL, SSMS, for example, or using the API also. And another functionality here, point-in-time retention from managed instance. You can use also PowerShell, the API, or the the portal. Long-term retention, it's like point in time, but this is more for a long term where you have the ability to actually extend it to many months, and I believe to the years. I don't have the information handy at this point as it changes frequently. You can leverage those backups also with PowerShell or the API. Finally, for managed instance, you can do geo backup, geo restore using API portal and PowerShell. And finally, if you really want to go the classic way of backup restore, where you just back up your database, copy into blob storage and restore, you can go and execute without the checksum. For everything else you see here, checksum, it's either performed for you behind the scenes, or you will need to enable for all this to work. But if you're doing a standard T-SQL operation, you don't need the checksum enable. Now let's go through the migration steps and automation. What you see here behind these somewhat pink boxes, it's what we're gonna go through today at scale for migration. But let's get to the basics, right? First, we need to perform a pre-migration process or steps. Then we go through that migration, and then we go through the post-migration. For the pre-migration, there are certain things that need to happen. You need to discover and assess, right? Today, we're not going to talk about convert. In some cases, this is going to be required, particularly if you're coming from a database that has objects that are not really compatible, or different databases that are not necessarily SQL Server, right? We can discover and assess at scale. You will see later. On the migration piece, we need to, of course, migrate schema and objects. We need to synchronize the data sync using data sync or a methodology of data synchronization. And then we need to cut over. This can also be done at scale. So assuming you're coming from a SQL Server environment, it's very likely that you're going to be always within these pink boxes, and you can fully automate it at scale on the presentation we're going to be providing later today. You have post-migration processes, not entirely our core today, but we're going to go through a slide at the end so you can see what are the options for you to ensure that this is something that's going to be workable for your environment. This is just an example of future state architecture of what's going to happen for your migration. We have classic examples of clients saying, I have my own instance with 20 databases. I would like this to be migrated to a managed instance with 20 databases. So what you see here in option 1, it's really that. Clients that have 80 databases on a single instance will end up on 80 databases on its own managed instance. If they are migrating 20 instances, they will end up with 20 managed instances. On option number 2 is ability to consolidate. It's feasible, and this has also happened, that customers will have multiple databases in multiple instances, but they would like to consolidate them into one instance. In this case, one managed instance. So those opportunities of assessing and landing them, of course, will need to be exercised before you start orchestrating your automation and scaling, because you can configure this on your scripts to happen that way instead. You can end up with 10 instances with 10 databases each on just one managed instance and 100 databases. Of course, making sure that you don't go beyond the limits of the storage that are currently in place. With that said, I will give now the opportunity to Avnish to discuss the scaling piece of DMA and DMS.
Yeah, no, thank you, Oscar. Hello, everybody again. So as Oscar mentioned, in the migration workflow, first step in the migration is the assessment of your on-premise environment. to understand the compatibility between your on-premise environment and Azure SQL MI target platform in this case. And we have a service called Azure Migrate. Azure Migrate is a great service which you can use for a single pane of glass as you assess your on-premise environment. And you can upload the assessment for your VMs where applications is deployed, and also your database assessment report into Azure Migrate. So it will tell you which servers are 100% ready for the migration, which servers you have to make some changes to make it compatible to your on-premise environment. And it also provide the sizing guidance based on the workload you're running in your on-premise environment, which you can use for the cost analysis as well, that if you're migrating workload X to Azure, what will be the cost of running that workload in Azure environment. Now using DMA, you can assess literally hundreds of databases, tens of servers in your on-premise environment. And we will talk about the techniques, the best practices we will use as you do the assessment using Data Migration Assistant in your on-premise environment. And some of the best practices we have here, we want to that if you have a database where you have a lot of database objects, literally hundreds of procedures, functions, then it's a good idea to have a separate DMA assessment just for that database. And we also recommend that not to run the DMA on the database server itself. Deploy DMA on a separate machine, which has enough capacity to scan through hundreds of databases you are planning to assess as part of this assessment process. And it makes sense, group your assessment into based on the applications, based on the nature of databases, and definitely for the production databases, you want to do the DMA assessment during the peak, during the off hours, whether you do it after the business hours or you do the assessment during the weekends to minimize the potential impact on the production workload. So this is a sample configuration file which you will put together before you do the DMA assessment. So what we have here, we have instance name. So you will specify the server where your database is, which the database you want to assess. So you specify the instance name, you specify the database name. So you have to put together list of databases servers you are planning to assess in a single assessment process. And here you can specify whether you want to upload the output of DMA assessment into Azure Migrate service or not. So you will specify the subscription ID. You will specify the project name, which you will create in Azure Migrate, resource group name, authentication, how you want to do the authentication, whether you want to have the interactive authentication. So when you upload DMA assessment, it will ask for the authentication. And you specify the tenant ID. And finally indicate whether you want to upload those that results into the Azure Migrate or not. So that's a configuration file you have to build before you do the DMA assessment. And this is just a so by default, your DMA would be deployed in C program files, Microsoft Data Migration Assistant. And you will see this executable dmacmd.exe. That's the binary we will use for the DMA assessment. And so this is basically assessment name, assessment databases as we discussed. So you can specify everything either on the command prompt, or you can build that XML file and just specify assessment name and the location where your XML file is located. You can also use the PowerShell. So we have a PowerShell commands for DMA assessment as well. But in this case, we will use DMA command line option and not the PowerShell for the DMA. So here is the example on how you will call DMA. So you DMA cmd.exe, action is assess. We are assessing those databases and the location where your configuration file is located. And towards the end, before DMA is almost ready to finish, you will see the summary of the assessment. So in this case, we assessed 5 databases, all completed successfully, 0 failures. And those databases were deployed on 2 instances and both completed successfully. You have the JSON output as well as the DMA output, which you can review in the DMA tool. And then finally, you have the log file, which will be generated as part of the DMA assessment. This is the output from the Azure Migrate. So you will see this information in Azure Migrate. So in this case, we did the assessment of 2 database instances, total 5 databases, and how many databases are ready for the migration, both on the different deployment options Oscar discussed, whether it's Azure SQL DB or SQL MI. And as you do multiple assessment of your on-premise environment, those results will continue to accumulate in Azure Migrate. So in this case, we did another assessment of another database on the same instance. So now you can see the count increased by 1. We had 5 databases before. Doing another assessment, added another database in the report. And this is again output from the DMS from Azure Migrate. So you can see instance name. We are hiding some sensitive data here. Readiness. So you can see both the instances are 100% ready for the migration. Instance version and number of databases. And then you can see further similar information for each database. So you have database size, you have target environment, and migration blockers, change count, and so forth. So all that information is readily available for Azure Migrate after you do the DMA assessment. And that's a very good piece of information for your management, because it will give them quick glance that, okay, out of 100 databases, 90% of my databases are ready for the migration immediately, and 10% databases would require some changes to make it 100% compatible. Now, once you do the DMA assessment and understand how many databases are ready for the migration, then second piece is migrating those databases from on-premise to Azure. And that's where we have Azure Database Data Migration Service, DMS. So DMS is the service which you can use for the offline migration as well as for the online migration. Now, when you are doing the online migration, you will provide the backups, both the full backups as well as the transaction log backups. And DMS, as part of the workflow, will upload those backups into blob storage, will initiate the full backups, restore from the full backups as soon as full backups are available in the blob storage, and will continue to apply the transaction log until you initiate the cutover. So it really allows you to reduce the downtime for these migrations from literally to few minutes, like 10, 15 minutes, and your database would be migrated from on-premise to Azure SQL MI. Now, there are certain prerequisites for the DMS migration. You must have a DMS. So DMS is provisioned in the VNet. So you must have a site-to-site connectivity or express route between your on-premise and Azure environment. And you will provide the endpoints for the target database endpoint, storage endpoint, and service endpoint. So there is a public-facing documentation. You will see all that information available. And you also have to enable some NSG rule, network security group rules, to unblock these ports 443, 53, 9354, and so forth. And login, and you must have sysadmin permission both on the source as well as on the target. Provide the backups of your source databases in the network share, and then service account for source systems must have write privilege on the shared network drive. Once you have all these prerequisites and DMS, then from the supportability metrics point of view, we support SQL Server 2005 and above. So if you have any legacy databases sitting in your on-premise environment, you can migrate those databases to SQL MI. And if it makes sense, you can run those databases in the compatibility mode, while your SQL MI platform is still on the latest version of the SQL Server. Now within DMS, for a single DMS service, you can have 2 parallel activities, and within each activity, you can migrate 4 databases in parallel. So altogether, using one DMS service, you can migrate 8 databases in parallel. But if you have hundreds of databases, you can provision multiple DMS services, and that's the way you can scale your migration. And like we discussed, using DMS, you can migrate those databases with minimum outage. So you can migrate hundreds of databases with a 15 minutes cutover window. Finally, you would have a separate folder for each database backup. And if you have literally hundreds of databases, then it would make sense to have a multiple blob containers for your backups to upload from on-premise to blob container. Now, there are certain best practices you should consider when you're doing the migration using DMS. So size of the database is very important and to feed into your DMS planning. If you have database over 1 terabyte, then we recommend to have a dedicated DMS service for that migration. And if you have databases between 500 GB and over terabyte, then maybe have separate database for each activity. So within one DMS service, you will have up to 2 databases to migrate and so forth. So if you have a lot of databases which are less than 100 GB, you can migrate up to eight databases within the single DMS service. So this is just a graphical representation that you have multiple DMS service, and each DMS service has up to 8 database. And you are basically doing the large scale migration from from on-premise to SQL MI multiple instances. Now, as you do the migration to SQL MI, there are certain prerequisites for SQL MI as well. And your SQL MI instance require a dedicated subnet. So within the subnet, within the VNet, you can have a separate subnet for SQL MI and another subnet for DMS. So that way you don't have to worry about any kind of a VNet peering if you have DMS and SQL MI instances in separate VNets. Your SQL MI subnet must have dedicated permission to Microsoft.SQL/managed instances. And again, all these prerequisites are documented in the public facing documentation. You also need to think about subnet size. We require minimum 16 IP addresses per SQL MI instances. And if you're planning to have tens or hundreds of SQL MI instances within a single subnet, you just need to make sure that you have enough IP address range to support that scale. And from the provisioning point of view, if you're provisioning a SQL MI instance in a brand new cluster, then it can take up to 4 hours to provision SQL MI instance. Versus if it's an existing cluster, then it will take roughly 2.5 hours. And same applies to the scale up, scale down operation. So, you will everything is online operation. It just takes roughly 2.5 hours to scale from, let's say, 4-week core to 8-week core, but entire operation would be online. Now, so in the demo, these are some of the things we will cover as part of the demo. The DMA assessment, how to upload those DMA output into Azure Migrate. And finally, using PowerShell script, we will migrate few databases deployed across 2 SQL VMs to SQL MI. So in our demo, we have SQL Server 2012 and 2017. And total 5 databases we're going to migrate from these 2 servers to SQL MI instance. In this demo, for data migration assistant, we will use 2 SQL servers deployed on Azure VM, SQL Server 2012 and SQL Server 2017. The target platform for this assessment would be Azure SQL Managed Instance. And we will upload results of DMA into Azure Migrate, which would be a single pane of glass to review results from all the different DMA assessments you will do over the time. Because goal here is to use these tools for the migration of hundreds of SQL servers from your on-premise environment to Azure SQL MI. And before we start the actual migration, we want to make sure that all these servers are compatible to Azure SQL MI. And if you have any gaps, or if you need to make any changes in your source environment, we identify those compatibility gaps using data migration assistant. So that's the first goal. Once we understand the compatibility and we are sure that all these servers databases are compatible, then we will have database migration services to migrate all those databases from on-premise to Azure SQL MI. Now, before we start the DMO, data migration assistant demo, this is my Azure subscription where I provisioned SQL Server 2012 VM, and I have SQL Server 2017 VM as well. These are the two servers we will use for the assessment. So on 2012 VM, I have two databases, AdventureWorks 2012, AdventureWorks DW 2012. And full backup of those databases I have on this full backup folder, which is a shared network drive. And we will use the shared network drive during the DMS migration. For DMA, it's not relevant. Another server we have is SQL Server 2017. On this server, we have these 4 databases. Again, we have full backup of those databases onto this shared network drive. Now for the DMA assessment, we need to upload this DMA tool from the Microsoft website, which takes literally a couple of minutes. And as Oscar mentioned, we want to make sure that we install DMA on a VM which has enough capacity. And by default, your DMA would be installed in C:\program file / Microsoft Data Migration Assistant. And here you will have DMA cmd.exe. But before we start the DMA assessment, we need to prepare the configuration file to specify which database, which server we want to do, which we want to use for the assessment, and whether we want to upload the results onto Azure Migrate or not. So this is my configuration file. And on this configuration file, these are the databases I specified for the assessment. So these are my 2017 databases. I have the host IP, the database name, user ID, and the password. So you specify this information for all the databases you want to assess. And then finally, here I have the information to indicate whether I want to upload these results into Azure Migrate or not. So subscription information, Azure Migrate project, your resource group where project is deployed, authentication information, tenant ID, and whether you want to upload results into Azure Migrate or not. Once you have this configuration file prepared, then final step is to initiate the DMA assessment. And to do that, you specify DMA cmd.exe, action equal to assess, and assessment configuration equal to path where your configuration file is deployed. And you press enter. So because the security authentication is interactive, it will ask for the authentication information. Once you specify, it will wait for me to approve the request. So it will take me a couple of seconds to approve this request from my device. So it's 49. So maybe another second and before it, so there it is. Now it will start assessing all the databases we specified in the configuration file. And for each database, it will review the databases, it will review the procedure functions code to identify the compatibility. So it may take some time depending on the number of databases, size of those databases. It's not the size of the database itself, it's the number of objects you would have in the database itself. So in my case, all the databases are pretty much same. It will take another couple of minutes to complete the assessment. So maybe another couple of seconds and we should be done with this assessment. Almost there. So there it is. So we are at the final steps, or it's completed. As you can see, we had total 6 databases. All the 6 databases completed successfully. We had 0 failure, and we had 2 servers which we assessed, all completed successfully, and 0 failure. The JSON output for this assessment is located in this location, and the log file is located here. So when you look at this, here is the location where I had the JSON file and the DMA output. So DMA output you can open in the DMA tool. And here you can see both the servers. So for each server, you will see the feature parity gap. So in this case, I have 0. And let's review the compatibility issues. So for 2012, I had 2 databases. And it basically will walk you through the compatibility issues for each different SQL Server version. And it will identify whether you had any breaking changes, behavior changes. In this case, I had one breaking behavior change. So full text search is changed since 2008. So it provides you the recommendation. It will provide you fix. And if you have any deprecated features, it will provide that information as well. And finally, informational issues. So for each database, you would have the information, and it will really help you to understand the compatibility and see whether server or database is ready for the migration or not. And finally, as we discussed, we uploaded those results into Azure Migrate as well. So here on Azure Migrate, if I click on Assess and Migrate Databases, I have the results uploaded into this project called PASS DMA project. And we had 2 database instances. So both those instances are 100% ready. And you can see the number of databases we did the assessment. And if you come back, you can see the databases we assessed. For each database, we can see size of the database, the target environment. If there are any blockers, it will indicate the count for each database, breaking changes count, and ready for SQL DB and SQL VM. So this DMA assessment can quickly identify which server, which database is ready, which one has gaps. And this Azure Migrate is a very good dashboard for your management to come and see, okay, we assessed X number of servers. Out of these X, 80% are ready for the migration to SQL MI, and 20% we need to make some changes. And based on the changes, you can decide whether you want to do the retrofit and get it ready for the SQL MI migration, or maybe you want to migrate those to Azure SQL VM or Azure SQL DB. It really depends on the findings we find from the data migration assistant. So hope you find this demo helpful, and it will really help you to, hoping that it will help you to prepare for these massive migrations you're planning for your on-premise environment. So in the previous demo, we talked about data migration assistant and how we can use DMA to assess your on-premise and on-premise environment, understand the compatibility for the databases you're trying to migrate to SQL MI, how many databases are ready, how many databases will require some refactoring to make it compatible. Now we will talk about DMS and how we can use DMS to migrate hundreds of databases with minimum outage. We have done successful migrations of hundreds of databases with less than 30 minutes outage. So again, in this demo, we have 2 SQL Servers VM deployed on 2012 and 2017. Both these SQL servers are residing in the target platform for this demo is Azure SQL MI. We will also have the blob storage, which DMS will use to copy the backup from the shared network drive to the blob storage. So before we start the demo, let's look into the portal. So this is my SQL MI instance deployed in West US2. It's using general purpose 4V core, 256 GB storage. And in the compute and storage section, you can see support from 4 to up to 80V core scalability. Your storage can scale up to 8 terabyte. And if you want to switch instance from general purpose to business critical, you can do it here. You can also scale the compute from 4V core to up to 80V core. And you can also apply the hybrid benefits. So if you have on-premise SQL servers and you want to leverage those licenses for SQL MI, you can do that as well. For the connection string, if your application is web-based application and you require your SQL MI to have the private endpoint, the connection string for private endpoint would be your server name, which is highlighted here. So this is your server name or host name for the SQL MI instance. And the port number for public endpoint is 3342. Endpoint, which is the default option, it's 1433. We also support the Active Directory integration. So you can leverage Active Directory integration to authenticate to your SQL MI instances. We also have the feature to restore deleted databases. So if you have a database which you dropped accidentally and you want to restore it later on, you can come back here and specify the point in time and restore the database. So there are a lot of features which are available through the portal, and obviously all these features are also available through PowerShell, CLI, or REST API calls. We also have disaster recovery options. So one is geo restore or geo backups, but you can also set up a failover group for your primary instance. In that case, you will have a second instance sitting in another region with a continuous replication between those two instances. You can initiate the failover through portal, or you can also again do it through the command line or PowerShell scripting. We also have the listener endpoints for read-write and read-only endpoints. So if you have an application where you want to scale out a read-only workload, you can use this read-only instance or read-only endpoint to scale out read-only workload. We also have this DMS service, which again provision in West US2, and we are using premium 4V core. So premium SKU is required for the online migration. If you have all offline migration, you can do standard DMS deployment. Now in this DMS service, we don't have any project, so we will create the project as part of the demonstration of this DMS service. Now my PowerShell script had some sensitive information like subscription information, username and password. So I copied this entire Power script in this Word document and took out all the sensitive information or masked the sensitive information so that I can walk you through all the steps I had in my PowerShell script. So first step is to connect your Azure account. Then you specify some of the configuration information you would need for this DMS migration. So which subscription you want to use, resource group where your DMS service is provision, name of the DMS service, location, your target SQL MI instance and target SQL MI instance. You select the subscription here. And then we have this app ID, which you will use to connect your SQL MI instance. And you will provision this app ID through the portal, or again, you can do it through the PowerShell. But here we are basically specifying the app ID, app key, and we are creating this object, which we will use in the DMS script here. This is my project name. This is the step I will use to create the project in DMS, and I will show it in the PowerShell demo. Here I have my source server information. So this is my SQL Server 2017, IP, host name, username and password. I'm creating this source connection information. I'm defining the securing the password. So I'm encrypting the password information here. This is my backup shared information. And I'm creating this file share object. Once you have this information, then you identify or define the storage location, storage blob storage container. Now I'm building the list of databases which I want to migrate in this demo. So I have 3 databases on 2017. So this is my source database name, and this is my target database name. So I have 3 databases here. I'm building this database object to hold the information about these databases which I just defined here. Once you have the database object for all the databases, I have this target SQL MI connection information. I'm creating this connection information. And now I'm creating the migration task. So I have this command. I specify the project name, DMS service name, source connection, target connection, selected database object. I build file share and so forth. Once you have the migration task, then you can check the status of the migration task from the monitoring point of view. You can check the status of the task. And then this is the command you will use to do the cutover. So in my demo, I will pass the database name one by name, but you can automate this entire process. And that's the whole idea. Even though I will execute these steps separately, but you can have this entire script to manage end-to-end DMS migration process. So this is the script which I will use to execute some of the steps we just talked in the script here. So this is my PowerShell. And so now I will start with creating the DMS project name. So if I come here, I'm creating this project called PAS01. So if I come back in the portal and refresh here, there is the project I just created here. Now in this project, I don't have any activities. So I will create these activities as part of the demonstration. So I'm going to basically define the source connection information here now. And after that, I will create the backup file share. I will define the storage container. And now I will build the list of databases I want to migrate here. After that, I'm going to create this selected database object for 2017. I missed the. So now if I look at this selected database object for 2017, I have the source database information, target database information, and the backup file share location I specified in the previous steps. After this, I will define the target information. So SQL MI connection string. And once I have this, I basically have the list of databases I want to migrate. I define the source connection information. I define the target connection information. So now I'm ready to execute or create that migration task I will use to migrate those 3 databases. So this is my migration task. And if I come here and refresh, I will see this migration task. If I click here, then you can see that I have 3 databases which I specified, and all these databases are now doing the full backup upload and should be ready for the should be ready to start applying the transaction log if I had any. Now, after this, I'm going to repeat the step for 2012 as well, and we'll go through the cutover step soon. So now I will create the task for 2012. So I'm just defining the variable. And now this is my connection information for 2012. Okay, so again, if I look at this, so now let me build the list of databases for 2012. So in 2012, I'm just using 2 databases. So altogether in this demo, I will have 5 databases deployed across 2 different SQL servers. Now I will build this selected database object. So let's look at the selected database object for 2012. So I have 2 databases and the file share information for those databases. Now I'm going to create a task to migrate those 2 databases. Okay, let's look into the portal. So if I come back here and do the refresh, I have 2012 as well. And both the databases are ready for the doing the file full backup upload. Now let's look at the status of some of those tasks or activities we created. So if I look at the migration task 2017, this is my migration task here. And I will do the same thing. I can check the status of this task. So it's running. And your task can have a status either running, queued, succeeded, failed, or failed input validation or faulted. So these are the validity status you will see in the task. Now, after that, I will repeat the same step for 2012. So let's do the 2012 status check as well. So that one is running as well. So both the tasks are running successfully. Now I'm going to execute the cutover for a couple of databases on 2017. So this is my 2017. And if you look in the portal for SQL MI, I have these 5 databases which we just migrated using DMS. And all those databases are in the restore status, waiting for the cutover. So I will do the cutover for first database on 2017. And if I check the status of command here quickly, you will see that it's accepted. And if I come in the portal on SQL MI and do the refresh here, you will see one of the database online. So this is my 2012 database online. I'm going to repeat the step for another database on the same server. So this time I will do 2014. And let's quickly do the command here. Again, it's accepted successfully. And in the portal, if I come back on SQL MI instance and do the refresh here, I will see one more database online as well. So this is my 2014 database. So finally, I will repeat this step for one of the 2012 database. So this is my 2012 database. I will do the cutover. The command is same. I'm just changing the source server and the database. If I come in the portal here and do the so now I have let's refresh one more time. I have 3 databases which are successfully migrated and 2 databases are still waiting for the cutover. So you can plan the cutover in the phased approach, or if you want to cut over all the databases simultaneously, assuming they are ready for the cutover, you can do that as well. So I hope this demo is helpful and it will be helpful in your planning as you migrate hundreds of databases from on-premise to SQL MI using DMS. Oscar, back to you.
Thank you, Avnish, and thank you very much for the demo. One of the things we would like to make sure that we go through after a migration is to ensure that the environment is efficient enough. One of the ways we can make sure that happens is by we have we're running statistics, we actually are able to make sure the statistics are up to date. That's something you can run. Depending on the size, it could be portions of your tables, if not the whole tables. You can also consider defining indexes or recreating those indexes for those databases that are very old, that haven't been taken care of in the past, just to make sure they are efficient and very well packed. And also ensure your database is sized for growth and optimal performance and experience. You want to make sure that you have enough cores and enough storage allocated. If you are migrating a database that is 500 gigs, don't just enable 500 gigs of storage. Make sure you have enough space for growing the next year or two. These will be the three basic things that you would like to ensure it's happening for your databases to run the most efficient way. One final thing, and this is something coming from the DMA, consider on upping compatibility level up to the level that DMA recommends you can run. In some cases, it could be 120, or in some cases, it could be 150, which is the latest. And with that said, we can get into the Q&A session. Let's get started.